Hello everyone, my name is Thomas Kim. This session continues from my previous video, Conversion Operator in C++, std reference, std wrapper. This is second video about std reference wrapper. If you haven't watched this video, please watch it because we will pick up where we left off in our previous session. This is the state of our previous code. This is the state of our previous session. I will give you a question. I declare a double reference pi 22.0 divided by 7.0 like this. Will it work? Now let's try it. CLS. With the Gnu Compiler, please note that this is test ref cpp. This file. Compile. No, it doesn't. 53. So at 53, it does not work. It does not work. Now, what about this? Constant double pi 22.0 7.0. Will it work? Yes, it works. Now let's try it. Yes, it works. It doesn't work. It does work. Why? I will explain the reason why in some future sessions. The simple answer is there is a dark history about this constant reference. If it doesn't work, it should not work. But it works. Constant lvalue reference work with rvalue assignment. lvalue reference with rvalue does not work. But lvalue reference, constant lvalue reference work. The reason why it works, the reason why constant lvalue reference works is that it has dark C++ history. About this, I will explain in some future sessions because we are concentrating on reference wrapper class. Okay, let's keep going. When we design reference wrapper class, we declared a member constant lvalue reference. This is lvalue reference. Constant lvalue reference as member field. And this constructor takes constant lvalue reference. So it works. Talk play fun. Reference wrapper int crw 5. Because constant lvalue reference initialization with rvalue works, constant lvalue reference initialization with constant lvalue reference should work. So it works. Now let's build. Okay, it works. It works. Now let's try with the C++ standard library std reference wrapper int std rw. Five. Now it doesn't work. Let's try it. No, it doesn't work. 69. 69. It does not work. So to make compatible with the standard library, we have to disable this kind of construct. So to disable this construct, we are introducing another constructor here, reference wrapper. This is rvalue. This parameter is rvalue, so we introduce element t rvalue reference. Now we delete this constructor. Delete. Okay. Now it doesn't work. Now it doesn't work. Let's try. Okay. 67. Now it doesn't work. Now it does not work because 덕플레이폰 reference wrapper element t rvalue reference constructor is deleted here. This deleted constructor is to prevent initialization with rvalue reference. Before we move on, I will give you another dark history of C++ language. Click this button and we are adding one file, dark cpp, like this. I created a dark cpp and I will show you one dark history of C++ language. Include IO stream. I designed a class dark cpp public or private, whatever, int m public dark cpp m. I initialize with 0. This is default constructor dark cpp. We take an integer n, then initialize member I like this. We created two constructors. Don't forget trailing semicolon here. I have to say n like this. int main dark cpp d1 5, and I declare another variable dark cpp d2 and dark cpp d3 std cout d3 std and there. Now let's compile with GNU Compiler first. We are compiling with GNU Compiler dark cpp or deque. GNU Compiler works And now let's try with the Microsoft compiler. CL EHSC DAC CPP FE MEXE. We are compiling with the Microsoft compiler CL. Microsoft compiler does not work. Now let's try with Clang. We are now compiling with Clang. This is Clang compiler. Clang compiler also does not work. Now let's try with GNU compiler once again. I compiled with the GNU compiler. Then dexe is created. D3 displays 1. Please understand that Microsoft compiler and Clang compiler does not work at this line, at this part of code. Because if we examine this line of code very carefully, Microsoft compiler and Clang interprets this line of code like this. D3 is a function name. D3 is a function name because of the parentheses coming after it. D3 returns an instance of DAC CPP. So Microsoft compiler and Clang compiler regard it as a function declaration. So it does not work. Function D3 is declared, but it is not function call. Now let's disable this. Now it works. Now let's try with Microsoft compiler. Now it works. It is warning, but MEXE is generated. So MEXE works. Now let's try with Clang. Clang also generates warning. It is empty parentheses interpreted as a function declaration. So it gives warning saying this is regarded as function declaration, like this. There are many DAC histories in C++ language. DAC history of C++ language left many detrimental old remnants of C++ history. I will address these things in future session. Using keyword delete, now we can disable certain C++ constructors like this. At the beginning of last session, I listed 5 items like this. Now we covered std reference wrapper, how to implement it by ourselves. Also in last session, we learned how to define conversion operators in C++ from custom class to intrinsic type or other type, from intrinsic type or other type to our custom class. In this session, we learned how to disable certain constructors using keyword delete. We can also disable or delete operators using keyword delete too. About item 5, we have to be especially careful when we access elements of std vector or deque using pointer or address and references. I haven't dealt this item yet, but I will deal it now. lvalue reference was originally introduced to C++ language to relieve the programmers of the burden of pointer. Pointers can be declared and uninitialized. Uninitialized pointer can cause lots of problems to C++ programmers. To address this issue, C++ language designer introduced lvalue reference. C++ 11 introduced move semantic. By introducing move semantic, they introduced rvalue reference as well. And with the introduction of rvalue reference and move semantic, the old problem of uninitialized pointer cropped up again. With the introduction of move semantic with rvalue reference, the old nightmare of uninitialized pointers cropped up again with lvalue reference. Now let's see why lvalue reference become dangerous in modern C++ programming. I will first address Item 5, this issue. Especially careful when you access elements of std vector deque using pointer or references. I create a file, reference danger, cpp, include iostream, include vector, int main. We create a vector std vector int v1 1 2 3. So v1 is initialized to 1 2 3 3 elements. int reference, I would say just b, uppercase b1, b0, b1, 0. Okay, this is reference lvalue reference to the first element of b1. Okay, please understand this point. std cout b0 b0 std and there. Now let's compile with GNU Compiler. Reference danger cpp o gexe g. Okay, it works. b0 is 1 as we initialize, as we expect. Now let's make another problem. Capacity b1 capacity. Now we add some values for size t. I equals b1 size I less than capacity plus 1 plus I b1 pushback I disable it. Instead std cout b1 0 b1 0 std, and there. Okay, so we push back more elements to this v1 container. Now let's run it. Okay, now it works. Now I enable it. I enabled this. This is still referencing first element of v1, and disable it. If it works, then v0 should be displayed properly. Now let's build. C++ compiler built successfully. G. Now it's garbage. It's garbage value. Now let's display side by side. Compile once again. v0 is still 1. This first element of v1 is still 1. Like this. But v0 is garbage. Now let's try with Microsoft compiler. CL EHSC reference danger CPP FE MEXE. Okay, it compiles. In case of Microsoft, it displays properly, but this is not proper operation. I will tell you why. Let's change it with Clang. Clang also compiles. Clang gives garbage value. Microsoft gives proper value. I will change it to C. This is Clang. CEXE is Clang. I will change it to G. This is GNU compiler. M is Microsoft compiler. Let's try Microsoft compiler. Seems to be working. Clang, garbage value. GNU, different garbage value. So it's not working. Accessing container elements with reference is dangerous. For example, if we modify it like this, v0, I modified it now. Let's see what happens. With the Microsoft compiler, v0 is 10, v1 is 1. It should point the same element. This is reference. Microsoft compiler writes in the wrong memory, in the wrong place. Now with the GNU compiler, GNU compiler crash it. See? We see some crashes. Now with Clang, Clang also crash it. It's not working properly. It crashed. It is writing arbitrary memory. I will rename this function void reference danger, and here int main reference danger. This is for your reference later. Originally, std reference wrapper class was designed to share container elements with another container by lvalue reference, but it does not work like this. std vector int b 1 2 3 std vector std reference wrapper int br. We need to include the functional here. Then we share this element, v1's element, like this. v0, v1, v2, vr contains lvalue references to the elements of v. Now let's build if it works. This is clang. Okay, it works. But once we add more elements to b, this b, for size t, I equals 0, I less than capacity, plus 1, plus I, b, pushback, I. Now this b1, br does not work. std, cout, br, 0, br, 0, std, and there b0, b0. Now this br fails to work. Garbage value. Okay. With my Gnu Compiler, it is also garbage value. Microsoft Compiler, it seems to be working, but it is not actually working, so regard it as garbage value. The point is, if you don't understand the internal structure of C++ standard library, std reference wrapper is almost useless. We cannot know, or we did not know how they implement C++ standard library, but we have to understand some fundamental ideas how the standard library works. Otherwise, C++ language does not make any sense. In my next session, I will address, with the introduction of move semantic rvalue reference, the old nightmare of uninitialized pointer cropped up again with the lvalue reference. I will talk more about advanced C++ concept in future sessions. Please subscribe to my YouTube channel. Thank you for watching.